Can you hear me? Am I audible?
Hello?
Yeah, hi.
I can
Can you
hear
hear
you.
me? Okay, that's great. That's great if you can hear me. So yeah, you were telling you just had a basic kind of thing, basic kind of idea about NumPy. So yep, let's start with this reading. NumPy, short
But
form for.
can
Oh
you
yeah.
turn up your microphone some more?
Like is my voice low?
Yeah, it's a little bit low.
Give me a second.
Yeah, it's better now.
Just a second. Yeah, I'm adjusting that. I had books and everything. Meaty organize that stuff. So I hope now it's not much better.
No,
I
it's
don't know
better
if
now. Much
Zoom
better now.
has any option of increasing the
Better
microphone.
now. It's
Yeah, it's
already
on
better.
autos, but okay. Okay. So yeah, NumPy short form for numerical Python. Yeah, as you know, like it does internally, it does some numerical calculation and that stuff. It's just made for like that stuff. It's one of the most important foundational package for numerical computing in Python. So yeah, most computational packages providing scientific functionality using Python array object as the lingua. Okay, just leave that. The important thing is, okay, it stands for numerical Python, and what exactly it does like some kind of numerical computation in Python when you want to do that stuff. Obviously you can do that with basic Python thing, but it has some kind of advantages over basic Python data structures or data types. And some things you'll find in NumPy: multi-dimensional array. What do they really mean by that stuff? They are like, it could have dimension, like in generally we have two dimension, that one is x and one is y. This is like kind of a 2D graph, but if we add a third dimension, and the dimension right here, that's called z. If I talk about like just like this, a box or something, this dimension, like the depth, it's called z. So now this figure would be like a kind of 3D. But if I talk about these numpy array and their dimension, it means like a box inside a big box or something. Or you could just generally say something like this. Let me open. Oh, we have VS Code. Let's do in that stuff. Yeah, it's like a big list. Inside that big list, we have, another kind of list that's called, multidimensionality or something like that in general, a thing in things. So we are just increasing the dimensionality or that stuff. We can even further add some more kind of stuff in that stuff, this would be maybe 3 dimensions or something like that. But that's what they refer with like n dimension, or it has like multi-dimensional arrays. It has the functionality to store arrays inside and arrays inside and arrays, like as many as you want. Provide fast array oriented arithmetic operations and flexible broadcasting. That's like, those are the two main points. Array oriented arithmetic operation, what they really mean by that is, if in Python, let's suppose A is this list, it's like 1 plus 2 plus 3 plus 4. And if I just run this, it will take some time to load that. Let me add a heading. Come on. NumPy. Yeah, it's done. Okay. And if I do A multiplied by 3, will this run or something like that? So like, did you saw I was trying to multiply each number inside the list, but I got
Yeah.
a kind of unexpected result. What it did,
Yeah.
it's like it multiplied it by 3. You
You
could say like,
repeated it. Yeah.
yeah, repeated it or something like that, but I wanted something else. And by this array oriented arithmetic operation, they really mean by this, like in NumPy, if you do something like this, it would be really different. Like here, or maybe like down there, if I do something like a1 is equals to numpy.array, and inside that array I pass this list, so this list would be converted into numpy array. And now if I multiply this a1 with 3, you would clearly see the difference. Like, see, it was 1, it got multiplied with by 3. Like, every element, every value in the numpy array got multiplied by 3. But in our journal, basic Python data type, basic Python array or something list, it's basically called the list. If I did something like that, we got some like unusual results. So that's what they really mean by array oriented arithmetic operation. Like if you are trying to do some arithmetic operation like division, addition, multiplication, taking out the mean and std or that stuff, you could do that on whole of that array. That's what they mean by this point. And flexible broadcasting capabilities, but this they mean that you could basically change the shapes or that stuff. Like here I could really broadcast or merge two arrays. A1 dot reshape, I could just reshape into how many elements does it has. It has 2 and 4. I could do something like 2 by 2, and like see, I quickly kind of changed the even the dimensionality. Now it's like 2 dimensions because this is the outer list, and inside that list we have two different kind of lists. So it increased the dimensionality. Like it's like a main list, and inside that main list we are having two lists, and even though it changed the shape of that stuff. But if I like check the shape here, a1 dot shape, it's like simply 4. But here if I check the shape, let me store this into a2 and then print a2, and here I could check a2 dot shape. You will clearly see it has like 2 rows and 2 columns, like simply 2 rows, and then we have like 2 columns for this thing. And that's what they refer by broadcasting. Like you could simply broadcast, change shape, merge them, or change the dimensionality from 2 dimension like 2D to 3D, and from 3D to 1D, or flatten that stuff. I hope like I'm not like I'm just making you familiar with these, what they really mean. It's just journal kind of thing. So next point is mathematical function for fast operations on entire array of data without having to write loops, and that's a really great thing to have. Like remember, like in Python kind of thing, if you want to do something with this stuff, we need to loop that. Like right here, what that could be, let's think of a Python function. Maybe taking mean of this list. I don't have any function that can take mean of this list. For that I need to apply a for loop for I in a. Then I am like I even need to have a dummy variable m for mean, that's 0. And I also need to count, or maybe I can use the length function. Let me len of a, how much length is it has 4. Yeah, I can use that. So I'm like, okay, take I, maybe m is equals to m, or maybe plus is equals to I. I'm just looping through this list, taking one element and adding up that into this m, and at the end I'll add everything of this list in this m, and I'll get the answer, which is gonna be m. If I see here m is 10, so if I plus 1 plus 2 plus 3 plus 4, it's gonna be 10. And after that I need to divide that by length of the list, which is a maybe a something. Now I have the mean right here. But in this NumPy array we have a function that could do this stuff without without this much hassle or something. I'm like a2 dot mean, so they have provided these kind of quick functions to do that stuff without looping through any of that stuff. We also have other function dot add or something. maybe some. Let me see, what function do we have? All arguments, bigs, clip, data, flatten, std, like these type of things. Some, I don't know, that kind of stuff. So by that stuff, by this sentence, they meant that we have some kind of function that are way faster because they don't use loop or that stuff. And we're gonna discuss why everything in NumPy is fast. Like later on, we're gonna discuss why that's happening. What's happening at the back end. But okay, let's move to the next point. Tools for reading, writing array data to disk and working with memory mapped file. Okay, but like in short, they mean that you could really save NumPy array into your hard disk in like a NumPy file format. That's called like .npy. I guess we have worked with that. If I don't remember, like we could just do a2.save. I could just save this thing.
Oh, we haven't done.
Oh, how to do that? NumPy.save, I guess. Save, and then I can just pass the array, maybe the name of the array, new, and then I can pass a2. Right here you will see we don't have any file, but as soon as I will run this thing, I have this file which is like a file containing NumPy array data. Obviously I can't open this thing because it's the format of this thing is like NumPy array, and that can only be read or decoded by this NumPy thing. And next time I can use the same command numpy.load and enter, oh my god, this, I don't want hints, new.npy. That's all the meant by that stuff, like tools for reading, writing arrays to hard disk and working with memory mapped file. We're gonna discuss this in a while about this stuff, what they really mean by this memory stuff, but I guess this part is clear. We can read write. Oh, what's happening here? We can read write that stuff. Linear algebra, random number generation, and I don't know what the transform capabilities. So we can do all this stuff. AC API for connecting NumPy with libraries written in C, that stuff. So the good thing to remember is this NumPy is written in C, and that's one of the reason why it's kind of really fast because yeah, C is the most like efficient and the greatest language, or C++ or C hash or those stuff. Those are the best languages, and this NumPy array is written on that C language. So yeah, basically NumPy provide an easy to use API. Okay, leave that. Pass data to external libraries, low level language of external data returned to NumPy array. The feature has made Python a language of choice for wrapping legacy C++ for on code base and giving them a dynamic and easy to use interface. So yeah, one of the reason is the backend of the NumPy is written in this C. That's why it's like so fast and that stuff. And yeah, that's it. While NumPy itself, yeah,
I can't hear you.
you can't hear me?
Something happened.
Can you hear me now? Can you hear me now? Am I audible? Hear me now? Can you hear me now? Hello, can you hear me now?